we are going to do data sufficiency problem 292 from the Quantitative Review 2017. Okay? Now, this is what the problem reads. If two different representatives are to be selected at random from a group of 10 employees, and if P is the probability that both representatives selected will be women, is the probability greater than 1/2? So let's find out what the minimum number of women necessary is to have a probability greater than 1/2. Now, since the statement 1 mentions 6 out of 10, more than 1/2 of 10 is 6 out of 10. Let's start with 6. Now notice in the stem, the question stem, that it doesn't even specify that there are any women or that there are any men. This group could be entirely composed of men or entirely composed of women. It probably isn't, but it could be, because on the GMAT you always have to consider that they're asking you something which you would never get asked in everyday life. Okay? Because if the group were composed entirely of women, nobody would ask you what the probability of getting a woman was. It would be 1. It would be 100%. But anyway, you have to consider everything on the GMAT. So statement 1 mentions more than half. So more than half of 10 starts at 6. So if there were 6 women out of 10 people, the first person you chose, you'd have a probability of 6 out of 10 of getting a woman. And then you would have a probability of 5 out of 9. Okay? Now this would be 30 out of 90, which is 1/3. That is clearly less than 1/2. So with 6 women, the probability of getting both women is only 1/3. Now let's not try 7 women. Let's try 8 women. Because if we try 8 women and it still doesn't work, we know we need to move upwards. But if we try 7 women and it doesn't work, then we have to try 8 women. So it's better if we try 8 women. Okay? Now 8 out of 10 times 7 out of 9 is 56 out of 90. 56 out of 90 is more than 1/2. This is greater than 1/2, so that's good. I don't think it's going to work with 7 women. I don't think this is going to work with 7 women, but just let's try it just to be sure. 7 out of 10, 6 out of 9, that's going to be 42 out of 90. That is smaller than 1/2. So you need at least 8 women. So we've determined that you need at least 8 women to have a probability greater than 1/2. Now, statement 1 does not tell us that you have at least 8 women. It tells us that you have at least 6 women. So that's not sufficient. So we know we need 8 women. Okay, we've determined up until now that you need 8 women. We need 8 women. Okay? We need 8 women is the threshold. Fewer than 8 women, the probability that you'll get 2 women is less than 1/2. From 8 upwards, so 8 inclusive, you will have a probability that is greater than 1/2 that you will select 2 women. So now the probability that both representatives selected will be men is less than 1/10. Okay, so it's not so hard to calculate the probability. You could start with 1 man, you could start with 2 men, but it doesn't make a lot of sense to start to test 1 man and to test 2 men. It makes sense to test 3 men, because 3 men means if there are 3 men, then there are not enough women. So that would answer the question. If there are 3 men, then there are not enough women. So is less than 1/2. So 3 men, uh, okay, 3 men, you'd have 3 out of 10 times 2 out of 9, right? 3 out of 10 times 2 over 9. This is selecting 2 men. You would get 6 out of 90, which is 1 out of 15. So this is with 3 men. So this is with 3 men, 7 women. So the answer must be that's not sufficient, because with 3 men, the probability is less than 1/10. It says in statement 2, the probability that both representatives selected will be men is less than 1/10. That means there could be 7 men. Sorry, there could be 3 men, there could be 2 men, or there could be 1 man, because as the number of men decreases, the probability that you'll get 2 men also decreases. So it's not sufficient, because you could have, as we said before, we need 8 women. We need 8 women, which would mean the maximum number of men is 2. This is the minimum number of women we need, and this is the maximum number of men we can have. And statement 2 is not sufficient, because we could have we could have 3 men and 7 women, or 2 men and 8 women. So it could go either way. We could be on either. We have this threshold of 8 women. We need a minimum of 8 women for the desired probability. And here we could be on one side of the threshold, but with 2 men and 8 women, we would be on the good side of the threshold. So it doesn't work. Now, combining them is really not very useful. Combining them is not very useful, because our threshold is at 8. Our threshold is at 8. So combining them is really not very useful at all, because this basically this statement 2 doesn't help, because